This video goes through the composition of matrix transformations. Now, all that means is more than one transformation. So the matrix representation of linear transformations makes it easy to find the effect of one transformation followed by another. So let's think about if we wanted to reflect a point x, y, and the y-axis and then dilate the result by a factor of 2 from the x-axis. So number one, we're reflecting in the y-axis and we're dilating by a factor of 2 from the x-axis. So to reflect in the y-axis, that means that our x is swapping signs and our y is staying the same. So if you think about it, you've got a point on one side and it's moving to the other side. So x is swapping signs, y is staying the same. So that is why our dilation matrix becomes -1, 0, 0, 1. So you can see that there. So that's the reflection. We'd have to do that and we'd have to times it by our xy. Now the next one was dilating from the x-axis. So that means it's a vertical dilation where we're timesing by 2. So that means the x is staying the same and our y is being multiplied by 2. So our matrix for that, x is staying the same, y is being multiplied by 2. So we then have to do that. So the dilation goes in front of what we previously had. Okay, so you can see that this is going in front of what we just did. So therefore, the matrix that will achieve both transformations is the product of those two. But if you notice, our first one was A, our second was B, but when we look at what we need to multiply, it's B times by A. So if you want A and then B, you are going to multiply by BA. If we went the other way, we wanted B and then A, we'd have to multiply by AB. So remember, the order is really important in matrix multiplication because it's not commutative in general. So you have to remember that it's in the opposite way. So let's look at some examples. Find the matrix that corresponds to a reflection in the x-axis and then a rotation about the origin 90 degrees anti-clockwise. So let's think of the first thing is A, the reflection in the x-axis. So that means x is the same and y swaps signs. So the matrix for that is going to be 1, 0, 0, -1. Now let's think about the rotation. -90 degrees. So our rotation of theta is given by cos theta, negative sine theta, cos theta. So that's going to be cos 90 minus sine 90, sine 90, cos 90. So in our unit circle, we're up here. So 0, 1. So cos of 90 is 0. Sine of 90 is 1. So -1, 1, 0. So we have our two matrices. Now we want A followed by B, which means we're going to have to do b times by a. So therefore, we've got 0, -1, 1, 0 multiplied by 1, 0, 0, -1. Cross the row down the column, 0 times 1, -1 times 0, 0. 0 times by 0, -1 times -1 is 1. 1 times by 1, 0 times 0 is 1. 1 times by 0, 0 times -1 is 0. Okay? Next, a rotation about the origin by 90 degrees, then the reflection in the x-axis. So we're going the opposite way. So we're doing B followed by A, which means we want AB. So therefore, it's going to be 1, 0, 0, -1, 0, -1, 1, 0. So let's do that. 1 times by 0, 0 times by 1 is 0. 1 times by -1, 0 times by 0, so that's -1. Next row, 0 times by 0, -1 times 1 is -1. 0 times by -1, -1 times by 0 is 0. Now let's look at compositions involving translations. So find the rule for the transformation that will reflect xy in the x-axis and then translate it by the vector -3, 4. So first of all, we want to reflect in the x-axis and then we're going to translate by -3, 4. So reflect in x-axis. That means that our x is staying the same and y is swapping signs. So our matrix is 1, 0, 0, -1. So that means our image is going to be doing that reflection. And then we need to translate. Okay, multiplying these matrices, 1 times x, 0 times by y is x, 0 times by x, -1 times y is -y. So that gives x -3, -y plus 4. So therefore, the transformation is my x, y will map onto x -3, -y plus 4. Next one, find the rule for the transformation if the translation takes place before the reflection. So now, the last thing I'm going to do is I'm going to have to multiply. So now I'm going to need brackets to get my order right. So I need to work out what the translation is first. But I still need to pre-multiply by that that reflection matrix. So doing the translation would be x -3, y plus 4, and now we can multiply. So 1 times by x -3, 0 times by x plus 4, so that's x -3. 0 times by x -3, -1 times 1, -1 times y plus 4. So it's going to be -y minus 4. So therefore, the transformation is our xy maps onto x minus 3, negative y minus 4.